Okay, so in this week's video lesson, we're going to look at chapter 3.1, quadratic functions. Now really this chapter focuses on what's known as a parabola, which is another name of called a quadratic. But a parabola has certain key features to it. Most importantly, the vertex. So the vertex, you can think of it as kind of the apex of a parabola, or also known as a quadratic function. Vertex sits right here. Notice this parabola here is opening up. This one opens up. Because if I see my arrows, they are going up towards positive infinity. If my parabola was going down like so, this one opens down. So here's an example of an up parabola. Here's an example of one opening down. Now notice my vertex here is about my lowest point, also called the minimum. Here in my parabola that opens down, my vertex will still be here at the apex. And instead of a minimum, I would call this my maximum. So my vertex here is also known as my maximum. So most importantly, where is your vertex in a parabola? Right here. It's pretty much your starting point, and then your parabola goes symmetrically on both sides of it like so. Now I do say symmetrical because we have another key feature of a parabola, and that is what's called the axis of symmetry. So notice I have this invisible line here that goes right down perfectly through the middle of my parabola and crosses the vertex. This is your axis of symmetry. Now some other points to take away. If our parabola were to cross the x-axis, like it does here twice, these would be your x-intercepts. And here, where your parabola crosses the y-axis, this is your y-intercept. So the big key takeaway from here is labeling parts of a parabola, also known as a quadratic function. It's their vertex, which goes at your apex here. It's either going to be your minimum or maximum. I have an axis of symmetry that basically cuts my parabola perfectly in half and goes through the vertex. So it is a vertical line. I have x-intercepts and y-intercepts. Now you may not always have an x-intercept because what if my graph is up here? Notice it's not touching the x-axis. Or I could have my parabola like so, where it touches it once. So sometimes you may have 0 x-intercepts, sometimes 2, and sometimes 1. You will always have a y-intercept because our domain is all real numbers, meaning it will guarantee to cross the y-axis once. Now, one important thing to note about a vertex is, say we have any ordinary point here. Its coordinates look like x and y. X being our first point, y being the second one here. Vertex also has an x and y, but we don't call it x and y. It's labeled h and k. Now don't ask me why they picked h and k. Just know that h is referring to the x value here, the x coordinate of your vertex, and k is the y value, the y coordinate of your vertex. So when we talk about a vertex, we're looking for the h and k points. So when we're talking about writing an equation of a quadratic, we usually write it in what's called general form. And that looks like this. ax squared plus bx plus c equals, let's just say y, just because we want to graph this. So it's ax squared plus bx plus c. That's the general form of our quadratic. Now parabolas have a unique form, which is called vertex form. And for a parabola, vertex form looks like so. A times x minus h, remember this is my x coordinate on my vertex, squared plus k being my y coordinate of the vertex, and of course equals some y because we're talking about a graph. Important things to note, that your a's on both these forms will be the exact same number. And of course, my vertex, like I said, deals with the coordinates h and k. So why do they call this vertex form? Well, that's because we're simply plugging in our vertex right into this form. If I'm giving you an equation, you should be able to grab or pull the vertex straight from vertex form. And I'll demonstrate that right now. So what I have up here is two types of parabolas in vertex form. And what I'm asking is for the coordinate of the vertex. So I'm looking for my h and k for both of these. Now, remember what our vertex form looks like. It looks like y equals a x minus h squared plus k. Notice this minus comes with the formula. So does this plus. So when I want to write my coordinate here, I can disregard this minus. I just want to look at this 6. So my h value is my x. So here it would be, or I'll use a different color. It'll be 6. And my y, or my k value, is here. Notice it comes plus with the formula, so this is plus, so I'm going to keep it plus. So 5. So what is the coordinate of my vertex from my vertex form? What's 6? 5. I know you see a negative here, but remember that negative comes part of the form. Remember when we did transformations, you got to kind of think the opposite? Kind of applies here too. What is the difference of a positive number? You need to take that positive number and attach that to your coordinate. Now let's look at this one here. The k is pretty much straightforward. I have a plus k, minus 3. So my k is a minus 3. Now here, negative comes with my form, but I have a plus 5 here. How do you get a plus 5 out of a negative? Well, of course, it takes two negatives. So what is my h value? Well, it is a negative 5. So again, just like transformations, you got to kind of have to flip the sign to kind of think about it. What is the difference of a negative number, of a negative 5? The difference of a negative 5 is two negatives makes a plus, x plus 5. So when we're asking for the vertex, give me the k. Nothing should change there. Just write that number that as you see it, but flip the sign of the h. And we're flipping because that negative here is part of the form itself. Now you try it. Pause the video and see if you could give me the coordinate of the vertex. So what I'm looking for is, where does my vertex lie, my h and k, for this parabola? Remember, what comes standard here? A negative. I end up with a positive. So my h, only way to get a positive out of negative is to have two negatives. So I'm flipping this, and that is my h. So a negative 1 goes here for my h, and 2, I'm keeping my k exactly how I see it. So the vertex you should have gotten is negative 1, 2. Now, what if we are given the parabola in general form? We can't exactly find the vertex straight out of the general form. So one way to do this, to find the vertex, if we're asked a vertex, is to convert general form to vertex form. Now, I've done a lot of the work for you, so here's our general form. To convert from general form to vertex form, if and only if your a value here is 1, here's your equation. It converts into vertex form as y equals x plus b over 2. So we're taking this number here, divided by 2, squared, plus our c. So here's our c, and we're subtracting b over 2 squared. Doing this formula right here, if this is 1, will give us our vertex form. And right from this form, we should be able to see the h and k for our vertex. Now, if you look at general form, what if a is not 1? What if it's some other number? Well, the first step you have to do is to factor out an a, because we want this to be 1 in order to fit into our formula here. So if you factor out an a, take away from a, is with x squared. B, you have to divide it by a, because you're taking it out, and likewise with c. So here becomes your new formula if you happen to factor out an a. Let's do an example here. I have my quadratic, or parabola, as 2x squared plus 20x plus 42. First thing I want to do, because my a is not 1, step 1, factor out a. So I'll have y equals, my a is 2, so I'm going to factor out a 2. And when I take 2 from 2, I'm just left with x squared. If I take 2 away from 20, that's 10x. And if I take 2 away from 42, that's 21. Step 1. If this is not 1, factor out to make it 1. Alright, now for step 2, I just need to take my new parabola here and plug it right into my form. So I'll have y equals a, which I found to be 2, times x plus b over 2, where b is 10. So 10 divided by 2 squared, plus a, and again a is 2, times c, which is 21, minus b over 2 squared. So, 10 over 2 squared. Now that's all that's left is to simplify. So I have y equals 2 times x plus 10 over 2 is 5 squared, plus 2 times, let's see, 10 over 2 is 5. 5 squared is 25. 21 minus 25 is minus 4. And what is 2 times negative 4? That is negative 8. So going from general to vertex, I find that my parabola is 2 times x plus 5 squared minus 8. And from here, we should know to take this directly into what is our vertex? This is a plus. So that means our vertex at h is a minus 5, and our k is a negative 8. So one way to find your vertex from general form is to convert to vertex form and read it straight from there. There is another method of finding the vertex from general form that I'm sure most of you are going to be using. So it's kind of why I rushed the general to vertex form. And that is, find your h value, which equals negative b over 2a. And then once you have h, plug back into here to find your k, or your y. So let's try that on the equation, on the parabola we just did. So it says h equals, so I'll use a different color here, h equals negative b, and my b is 20, so negative b, over 2 times a, and my a is 2, so 2 times 2. So it equals negative 20 over 4, and of course negative 20 over 4 is negative 5. That is my h value. And did we not just find negative 5 as the h for the last problem? We did. So how do you find the k? Well, plug in negative 5 for x here and solve. And then you should get your k. Quadratic. So 2 times x squared plus 20x plus 42. Where in the place of x, I'm going to plug in my negative 5. Alright, let's simplify. So that equals negative 5 squared is 25, so 2 times 25, which of course is 50, plus negative 25, 20 times negative 5 is negative 100, so minus 100, and plus 42, plus 42. So what is 50 minus 100 plus 42? Well, that is negative 8. So it says my h is negative 5, and my k is negative 8. Is that not what we found in our last problem? Should have been.